the IMS Gate Academy? How are you all? Please do reply in the chat box so that I come to know how many of you are online over here. Good. So as you know that the GATE score booster has been started from the past couple of the days, and we have seen a quite good response from the student sides. So yeah, very thank you for all of you for such a wonderful participation in all our GATE booster session. So yesterday I had started the electrical machine GATE booster, and part 1 has already been completed on yesterday, and we have completed the 2 chapter, the first one transformer, and we had also completed the induction machine. So those who have not watched those particular session, once this session is going to be over, please go and watch those session as well. Definitely you will going to get a wonderful experience from the particular session. Alright, so myself Nikhil Gaurav, and as you know that I will be taking care here for the electrical machine, and mark my word, if you going to attend this particular session in a live manner, you will going to see a drastic change in yourself, and 100%, I am 100% sure that whatever question you are going to get in the GATE exam, you will going to fetch 100% marks in all the electrical machine questions. Okay. So yesterday I had given one question. How many of you have solved? How many of you have solved? All right. So please attempt those particular question which I had given as a homework, and please answer in the comment box as well. Whenever I get a time, I will definitely going to watch all the comments, and if there is any scope of the correction, I will let you know in the comment box itself. Alright. So in this session basically we will going to cover the remaining chapter, which is the DC machine and the synchronous machine, and this DC and synchronous is only for EE, it is not for IN. But my dear friend, it is my humble request that IN students they may also attend this particular session, because this will going to be helpful in the in your interview or in some of the state exams. Okay, so this is a part 2 in which we will going to cover the remaining 50% of the electrical machine syllabus, and whatever question that I have come up with, definitely you will going to experience such a question, such a concept that you have never ever imagined. Okay, so please be ready with pen and copy, so that whatever question I will going to show here, after that I will going to give you some time, like 1 minute, 2 minute, 3 minutes, depending on the level of the question, and on those particular span of time you will have to solve, like you will have to try to solve the particular question, and suppose whatever answer you are getting, please reply in the chat box so that I come to know that how many of you have answered the particular questions. Okay, so if you are having any doubt, please do let me know before we proceed with the session or the question. No doubt? Alright, so let us begin with the very first question, and before that let us see the weightage and the important topics. The weightage for the DC machine, which is basically in EE, 2 to 4 marks. Okay, so 2 is the minimum and 4 is the maximum. So it is average, it is not fixed, na? Okay, and these are the important topics. So whatever question you are supposed to get in the DC machine, this is basically I have come up with the data for the past 15 years, and I have seen the frequency of the question from this particular topic. Okay, so remaining you can skip, like the remaining topic in your DC machine you can skip, but you should not skip this particular 4 topics. These are very important with respect to the GATE exam, rather I should say with respect to the numerical type of question. Okay? So the first topic is torque and EMF equation, second one losses and efficiency, which is basically power flow, operating characteristic of the DC motor, and speed control of DC motor. Alright, so let us start with the very first question, and I'll be giving you 2 minutes for this. Okay, so your time start now. A 250 volt 25 kilowatt shunt motor has maximum efficiency of 89% at shaft load of 20 kilowatt and speed of 850 rpm. The field resistance is 125 ohm. Calculate the rotational loss and armature resistance. What will be the line current speed efficiency at an armature current of 100 ampere? So basically you are having the two part for this particular question. First we need to calculate rotational and armature resistance, and the next one is speed efficiency and current at 100 ampere. Okay, so let me note down the data so that we can save some time. Okay, so time's up. So look at here, this question is related to the DC shunt motor. Okay, now all the data I have written over here. For this particular diagram, for this particular question, we should be first clear about the power flow in the DC motor. So this is your the symmetric diagram of the power flow in DC motor. Now since this is a motor, what is input? Input will be electrical and output will be mechanical. So this is your input side and this one is your output side. So from the electrical, you will be having first stator, which is going to give, which is basically connected to the bus bar, and you will going to have the input into the motor. So this is basically electrical input. I am talking only about here the active power. Okay. So yeah, this is your stator in which input is what? P in. Now after this you are going to have the stator losses. So in the stator you are going to have two kind of loss. The first one, it is the copper loss, and the second one is your core loss. So here the combination of these two is what basically your variable losses. Then the next one, between the stator and the rotor side, you will be having the air gap such that rotor can rotate easily. Therefore, we should provide the air gap, means the gap between the stator and rotor. So this is what air gap, and the power which is transferring from the stator to the rotor side is known as air gap power, which is developed power, which is EA into IA. What is EA? Induced EMF, IA armature current. After that, you are going to have these losses: friction and windage loss, stray loss, and the rotor core loss. So this all together are known as rotational loss or fixed loss. So please do not get confused with the constant or the core loss or the rotational loss. In the DC machine, rotational loss is a combination of your core loss plus friction and windage loss plus stray loss. Most of the time this stray loss is assumed to be 0. Done. And after this you are going to have the shaft power or output power or net power. Done. So this is a power flow diagram. Now let us start with the solution part. Okay. Now one more information what we are going to get from this eta max, efficiency max. What is that? With with the maximum efficiency, we will come to know about one relation related to the losses. What is that? At maximum efficiency, variable loss or variable losses is equal to rotational losses. Okay. So when your variable loss becomes equal to the rotational loss, na, your efficiency is going to be maximum. Okay, all right. So my task is to calculate the rotational loss and the armature resistance for the first part. Okay. All right. So see, what is the formula for the efficiency? Let me write here. Efficiency, this is equal to output power. Let me write P naught, or in short manner, let me write here P naught divided by P in into 100%. So this will give you the efficiency. And what is P in? P in is your output power. कहाँ गया? Yeah, output power plus losses. Output power plus losses. Now my task is to calculate this P in, because P naught is given in the question as 20 kilowatt. I guess it is given 20 kilowatt. So my task is to calculate only P in. How I can calculate? It is not required to calculate P in power, because as I told you, P in is output power plus variable losses plus rotational losses into 100%. Now at maximum efficiency, which is given in the question as 89%, this is equal to P naught is 20 kilowatt, 20 into 10 to the power 3 plus, since these two losses are equal at the maximum efficiency, so can I say 2 times of P rotational into 100%? Any doubt? Any doubt? So from here, what is the value of rotational loss? Okay, what is the value of rotational loss? Give me the value. Give me the value. Let me calculate it. Okay, anything else which are given in the question? Okay, let us see. So this is equal to, just a second, let me calculate it first. So this is equal to 20,000 divided by 0.89 minus 20,000 divided by 2. So your P rotational, this is coming out to be 1235.95 watt. So this amount of rotational losses we are getting when the efficiency is maximum. Done. Now at maximum efficiency, these things are equal. These things are equal. Now my dear friend, see the variable losses which are given by the resistance, because in the resistance your current which is flowing as IA, see here, this is your DC shunt motor symmetric diagram or a circuit diagram, where in this branch you are having the resistance RA and this current is what, entering into IA. So this IA is variable in nature because it depends on the load. Okay, so ignore this part. This is not be the load. Just a second. Okay, ignore this one. Okay, because since this is a motor, so input will be electrical. So load should not be present over here. So there is a mistake in the diagram. Okay, extremely sorry for that. All right, now coming back here, you are having the resistance over here Ra and the current which is flowing as Ia. So can I say variable loss is equal to rotational loss? So Ia square into Ra is equal to 1. What is the value? 5.95 watt. Okay, so this will be the value. Now my task is to calculate this Ra, and I'll be having Ra value if I have Ia. Now how I can calculate Ia from the given data? See, this is Vt and values which are given over here. This is 250 watt and RF is 125. So let me write here. This is 250 volt and this RF or RSH both are same, 125 ohm. So look at here, ISH will be equal to 250 divided by 125. So this value is 2. Are yes or no? Yes or no? What about IL? What about IL? How I can calculate IL? If I have IL, I can have IA value. See, for IL, I will be using this equation. From here, I can get PIN value. How? From maximum efficiency formula, P in is equal to P output divided by efficiency. So P output is 20 kilowatt and P in is 0.89. Sorry, not P in, efficiency is 0.89. So when you solve this, you are going to get this P in as 2247.9 watt. Done. Now this is your electrical power, which is Vt into IL, 2247.9 watt. Vt is given in the question as 250 into IL, which is 2247.9. So from here IL value that we are getting, ये IL value जो आएगा, it will be 89.8876 ampere. So I have IL value, I have ISH or IF value, I can easily get IA. Apply KCL at this node. So we'll be getting IA as equal to IL minus ISH. So 89.8876 minus 2, so it will be 87.8876 ampere. Let me check. Yeah, this will be the value of IA. Now substitute in this equation. So from here 87.8876 whole square into RA is equal to 1235.95. So from here RA value is equal to, let me write the value directly, 0.16 ohm. So yes, we have got the RA value, which is means the armature resistance value, which is this one. So rotational losses we had got. We have got armature resistance. Now we are left with the second part, which is this one. Okay. Now in the second case, armature resistance is armature current is already given as 100 ampere. So can't we able to calculate the line current? This is your line current, IL. This is your line current. So your new line current, let me come here, given IA, which is equal to 100 ampere. So your IL will be equal to IA plus ISH. So ISH was 2 ampere because we have not changed the field resistance and the terminal voltage. So it is 2. So 100 plus 2 is equal to 102 ampere. Done. Okay. Now, kahan gaya? So we have got IL. Now come to the speed. How we can find the speed in the most expected concept of the electrical machine. I told you, like this was a series on YouTube which was free. In that I told you that whenever you are having a question from the DC machine and it is related to the, if it is related to the speed or the current, then we will going to use the EMF equation or the torque equation. So since it is related to the speed, so we will be using the EMF equation. See, for the first case it is given that 850 RPM when efficiency was maximum. So the first speed is, anyway it is given in the question. Now my task is to calculate the new speed. For that I will be require the new EMF. Okay. So look at here. As EMF EA is proportional to phi into N, and since it is a shunt motor, for the shunt motor flux is constant. So it is again equal proportional to the speed. So from here I can say EA2 means 2 is for the second case divided by EA1 is equal to N2 by N1. And what is N1? N1 is 850 RPM. 850 RPM means from the first case. So let me calculate EA1. So EA1, let me write here equation 1. Okay. EA1 is equal to VT minus, I am applying KVL in this loop. KVL in this loop. EA1, basically here I have written EB, so like you can use EA as well. Both are same. Okay. Only the difference in the notation, but the conceptual thing will be the same. Okay. So yeah, EB will be equal to, apply KVL here, EB will be equal to, or EA will be equal to 250 minus IARA. IARA means for the first case it will be IA1 RA. So 250 minus IA1 was this was the IA1 value which is 87.8876. 87.8876. Let me check once again. Yeah, 87.8876 into RA, what we have got, 0.16. So do I have this value? Okay, no issue. Let me find it. So 250 minus 87.8876 into 0.16. So I am getting this value as, everybody please check it, 235.94 volt. In the same manner, we can also calculate EA2, means for the second case when your armature current was this. So VT minus IA2 into RA. Only armature current is changing, rest are same. So 250 minus 100 into 0.16. So 250 minus 16, so 234 volt. Okay. So from equation 1, what is N2 value? N2 value will be equal to N1 EA2 divided by EA1. Substitute all the values. N1 is 850, which is given in the question. So let me find the value. 850 into N1 is 850 into EA2 is 234 and EA1 is 235.94. So I have the value as 843.02. Please check it, 843.02 rpm. Check it once everybody. 234 whole divided by 235.94. Yes, correct. Okay, done. So we are left with only one portion, which is the efficiency. So how we can calculate the efficiency? How we can calculate the efficiency for the second case? See, first we need to calculate the input power, okay, for the second case, which is Vt into IA2. Vt is 250, sorry, not IA2, IL2, and IL2 is basically your 102 ampere. This is IL2, 102 ampere. Done. Now come to the shaft power or output power. So this is equal to developed power or gross mechanical developed power minus rotational losses. Look at the power flow diagram. This power I need to calculate. So if I have this value, and from there I can subtract the rotational loss, which is always fixed. Whether your machine is running under load or no load, this value is always fixed. So EA, IA minus this, we will going to get the shaft power. So EA2 IA2 minus P rotational. So we have all the values. EA2 as 234, IA2 as 100, rotational loss was just let me see, 1235.95, 1235.95. Okay, so percentage efficiency, it will be equal to 234 into 100 minus 1235.95. This is output divided by input is 250 into 102 into 100%. So this is coming out to be as 86.92%. Everybody please check it whether all of you are getting the same numerical value or not. All of you are getting the same numerical value or not? 86.92, which is the correct answer for this question. Okay, so I hope you have enjoyed this question because we have discussed a lot of things. If you have able to get all the concept from this particular question, now you can solve any question which has been asked in the GATE exam. Okay, so this is how we are framing the question in our AIMTS or chapter test, or you can say the subject test. So if you are going to opt for our online courses or offline courses, any courses, definitely you will going to get this test series, and in which you can enjoy such kind of question. Okay, so my dear friend, let me take some couple of minutes of yours. Suppose if you want to enroll for the GATE 25 and for GATE 26, and if you want to prepare with us, then you can opt for the live online program, in which we are going to give you the program features as 800 plus hours of live classes with the live interaction, along with theory book of every subject, exercise books of every subject, and 30 plus years GATE question bank with video solution, which is very important. Okay, so you will be getting the video solution for the questions which has been asked in the GATE exam. Next, 12 personalized one-to-one mentorship session. It is the USP of the IMS GATE Academy. What is the meaning of one-to-one mentorship session? Here, student and faculty will going to be meet as one-to-one, and whatever general doubt the student are having, the faculty will going to rectify as soon as possible. Okay, so you will be getting the chance to meet to the faculty, and whatever general doubt, generic doubt, technical, non-technical, whatever doubt you are having, you can ask to the faculty, and our expert faculty will going to resolve all your doubts. Okay, and the next one is 130 plus online test with video solution of mock test and many more. Okay, alright, so if you want to counsel yourself, you can book a free counseling session by clicking on the link which is given in the description box, the link which is already given in the description box, or else you can directly contact over this 2 number. Either of this number you can give a call, and definitely you will going to have a clear idea about the our programs, or basically online programs. All right. So whatever thing that we are discussing in this session, like the question solution, the PDF of this particular session will be shared to our Telegram channel. Okay, so this is our Telegram channel, and the link is given in the description box, or else you can visit to this particular link. And in that, in our Telegram group, you will be having these features at free of cost: schedule of free YouTube lectures, PDF, important updates related to the seminar and webinar, PSUs and other government job notification, expert session on the important topics, and very important daily quiz, and many more. Our Telegram students are having the great experience, and they are feeling confident because they are getting the daily quizzes in the over the Telegram group, and those questions are very, very important as well, because if you are able to solve question, concept very, very clear. Okay, so this is all about our courses in the Telegram. So please do join our Telegram group. The link is already given in the description box. All right, so let us go to the next question. The question number 2. A 220 volt DC shunt motor takes 22 ampere at rated voltage and runs at 1000 rpm. Its field resistance is 110 and armature resistance is 0.1 ohm. The value of additional resistance required in the armature circuit to reduce the speed to 800 rpm when the load torque is proportional to the square of speed. So basically this question is related to the speed control of DC motor. Okay. So look at here. Let me give you 1 minute. Let me give you 1 minute. Meanwhile, I will write the data. Do it fast. Your time starts now. Time's up. Time's up. Okay, look at here. So this is the shunt motor. This is a DC shunt motor, where this is the external resistance. Let me write RE instead of REX. Okay, let us take REX. I have written here RE, so let me write REX. Okay. Now in the case 1, when REX or external resistance was not inserted, means REX was 0. Case 1, when external resistance was not inserted, means REX was 0 ohm. Then what would be the EMF? Why we are interested in the EMF? Because we are need to find the speed, and as I told you in the very first question, that whenever you are supposed to find the speed, then the EMF equation will always be required. Okay. So apply KVL in the armature loop like this, in this loop. So this is VT, this is EA, RA. Okay, all right. This is RSH, both are same. RSH or RF, both are same. Okay, in the case 1, what we are having, RSH value as 110 ohm, VT value as 220, this is 220 volt. Armature resistance is given, which is 0.1. 0.1 ohm, and let it be ISH1, IA1, and line current IL1. Line current, not the load current. Okay, so let us calculate EA1 in this case. EA1 means this value, EA1. So this will be equal to VT minus IA1 RA minus VBD. What is VBD? Voltage drop across the brushes. So since it is not given in the question, so we will take this VBD as 0. Most of the time this VBD we can take 0. If no information is given about the brush drop, we simply take 0. Now VT is 220, IA1 is unknown, so I can write IL1 minus ISH1 into RA. So 220 minus IL1 is given in the question as 22. What is ISH1? 220 divided by 110, which is equal to 2, into RA is 0.1. So this value is equal to, let me check. Okay, so 220 minus 22 minus 2, 20 into 0.1, it is 2, so this is equal to 218 volt. 218 volt. So this is the case 1. Now case 2, when the external resistance is added. So since this is a case 2, let me take VT plus minus EA2, ignore this one. RA is 0.1 ohm, VT is 220 volt, this RSH is 110 volt, let it be ISH2, this will be IL2, and this is IA2. Now when REX is greater than 0 or inserted, and now apply the KVL in the armature loop, we will get EA2 VT minus IA2, but this time you are having armature resistance plus REX. So what we have, 220 volt minus IA2 is unknown, IA2 is not given in the question. How we can calculate IA2? IA2 is unknown, na? IL2 is also not given. Okay, so let me write here IA2, RA is 0.1 plus REX. So if I have IA2, I will be having my answer. Now for that, will we be taking the help of the torque equation. Now under steady state, electromagnetic torque is equal to load torque. Now electromagnetic torque is proportional to phi into Ia, and since this is a shunt motor, flux will be constant because flux is generated by this field winding. Since both Vt and RSH are fixed, therefore ISH is fixed, therefore flux is fixed. So we can write electromagnetic torque is proportional to Ia only, and TL is proportional to speed ka square, which is given in the question. So can I write Ia2 divided by Ia1 is equal to N2 by N1 का होल स्क्वायर. ये तो दिया गया था क्वेश्चन में. Okay, this thing is was given in the question. So Ia2, Ia1 was 20, N2 was let me check, N2 was 800, N1 was 1000. 800 divided by 1000 का whole square. So from here we will get Ia2. I have the data, let me write it directly. Ia2 value as 16 ampere. So in this manner, whenever you are supposed to get the armature current, then please come to the torque equation. Electromagnetic torque equal to load torque. From here, definitely you will going to get a relation, or directly you can get the value of the current. Okay. Now substitute this IA2 in equation EA2. So EA2 will be equal to 220 minus, it will be 16, RA is 0.1 plus RE x. Done. Now as EMF is proportional to phi into n and flux is constant, therefore it is proportional to your speed. So can I write EA2 divided by EA1 is equal to N2 by N1. What is EA2? EA2 is 220 minus 16.1 plus REX whole divided by, this was 218. EA1, let us check. EA1 is 218. Done. And N2 by N1. N2 was 800, N1 was 1000. So from here, R external, because only one unknown is here, so R external is equal to, let me write it directly, R external is equal to 2.75. So the correct answer for this question is 2.75. So this particular question is very important, because such kind of question you can see in the GATE exam. Like this, such kind of question has already been asked in the GATE exam. Here I have added certain thing such that this particular question becomes lengthy. Okay, but in the GATE exam you may going to get some part of this question. All right, so I hope you have got the concept from this question. Let us start with the next question, which is this. Okay, a belt driven 100 kilowatt DC shunt generator running at 300 RPM on 200 bus bar continues to run as a motor when belt breaks, then taking 10 kilowatt. What will be its speed in RPM? Consider armature resistance as 0.025, field resistance as 50, and brush drop. This time we should not ignore the brush drop. It is given in the question as 1 volt. Ignore armature reaction, answer to nearest integer. So since this is a case of DC shunt machine, when first case when the machine was running as a generator, and in the second case when the belt breaks it runs as a motor, and when it is running as a motor, for that we need to find the speed. Okay. So this is the DC shunt generator. How we can say? In the generator the current will come out from the armature and it will enter into the terminal. So this is your electrical part and this is your armature, mechanical. Okay, so this is RSH, this is ISH, so this is EAG, let me write EAG, armature resistance RA. Okay, so let me write for the generator case ISHG, G is for generator, IAG, and this is ILG, and this is VT. Done. So look at here, the shunt generator was delivering the power to the terminal as 100 kilowatt. So your VT into ILG, this is given as 100 kilowatt. What is VT? VT is 200 volt, है ना, into ILG. This is 100 into 10 to the power 3. So what is ILG, my friend? ILG will be 500 ampere. Now let us calculate IAG. Why we are calculating IAG? Because I need to find EAG such that I can have the speed for the motor, and such that we can calculate the speed for the motor. Now IAG will be ILG minus ISHG. ILG we have calculated as 500 minus, what is ISHG? this voltage divided by resistance. So what is VT? VT is 200, resistance is 50. RF, this is RSH basically. So 200 divided by 50 is 4. Okay, just a second, this is motor, this is generator na, so plus will come, sorry, plus will come. So 4. So total armature current is 504 ampere. Got the point? Now EAG, EMF at the generator, apply KVL in this loop, it will be equal to VT plus IAG RA plus brush drop, please do not forget it, brush drop VBD. Done. So VT is 200, IAG is 504 into RA. RA क्या था? 0.025, 0.025 plus brush drop is 1. Okay, so what value we are getting? Let me check it. 200 plus 504 into 0.025 plus 1. 0.025 plus 1. So this is 213.6 volt. Now suddenly the belt breaks and your machine is running as a motor. So therefore, let me write ILM, IAM. This is EA2 for second case, armature resistance RA, RSH, ISH, M. M is for motor and this is VT. Okay, so the power the motor is taking is 10 kilowatt. Done. Like from here, the power which is entering into the motor is 10 kilowatt and this is equal to VT into ILM. So what is power which is entering here in the motor? Terminal voltage into current. So VT into ILM, this is equal to 10 kilowatt. VT is 200. Line current in the motor is equal to, ये कितना होगा ILM? जल्दी से बताएं. This is equal to 50 ampere. 50 ampere. Now let us calculate IAM. This is equal to ILM minus this current ISH. ILM is 50 minus what is this current? 200 divided by 50. So 4. This is equal to 46 ampere. Now EAM induced EMF is equal to VT minus IAM RA minus brush drop. So 200 minus IAM is 46 into 0.025 minus 1. So let me calculate it. 200 minus 46 into 0.025 minus 1. So this coming out to be as 197.85 volt. So this is your EMF in case of generator and motor. Now as EMF is proportional to flux into speed and flux is constant, therefore it is proportional to speed directly. So EAG or EAM divided by EAG is equal to speed of the motor divided by speed of the generator. So this was 197.85. EAG was कितना था? 213.6. NM we need to calculate and NG was 300 na? NG was 300. So कितना आ रहा है? 300 into 197.85 divided by 213.6. So this is 277.88 RPM. So the nearest value of this is what? 278 RPM. Let us see whether it is given in the question or not. 278 RPM. No, it is not given. So correct option is option D. Okay, alright. So I hope you have got the concept. See, everywhere we are using the two equations, either the torque wala or the EMF wala. Most of the time we will be using the EMF wala equation, means flux into speed. Okay, so this is multiple select question, means more than one option can be correct. A 4-pole series wound fan motor runs normally at 600 RPM on a 250 volt supply taking 20 ampere. All field coils are connected in series. Calculate the speed and the current taken by the motor if the coils are connected in two parallel group of 2 in series. The load torque increases as a square of the speed. Assume that the flux is directly proportional to the current and ignore losses. So we need to calculate the armature current as well as the speed. So here you are going to have the two cases when the field coils are connected in series, and the another case will be what? Two parallel groups of 2 in series. Okay. So look at here. Basically this question is related to the speed control of the DC motor. Now in the case 1, when all coils are connected in series, since we are having the 4 coils which are connected in series, so let me draw the diagram first. This is 1 coil, this is 2 coil, the second coil, this is 3rd coil and the 4th coil. Okay. So let us take the current, in this case armature current, as IA1, and if the total turn is T, can I say one turn will be T by 4? Similarly T by 4, means I have assumed total turns as T. So one coil will have T by 4 turns. Done. Where T is total number of turns. Again the question is related to the speed, then we require the EMF. So EMF, as we know that it is proportional to flux into speed. Now this time flux is not constant. Why? Because flux is MMF by reluctance. MMF is what? Number of turns into armature current, IA, divided by reluctance. T is the number of turns, it is not torque, na? T is number of turns. So assuming the reluctance to be constant, can I say flux is proportional to your MMF or number of turns into armature current. Any doubt in this question? So this time your EMF EA is proportional to number of turns, armature current IA and speed. Done? Okay, so look at here, how many turns we are having? How many turns? T by 4, T by 4, T by 4, T by 4, means in this, what is the flux generated? The flux generated by this coil, this coil, this coil and this coil. So total turns, let me take EA1 for the first case. EA1 is proportional to total number of turns as T, armature current we had taken as IA1, and speed at which the motor is running as N1. Done. So let me take equation 1. Next, torque wala equation, because we need to calculate the armature current. So torque equation TE, electromagnetic torque, this is again proportional to flux into armature current. Now as I told you, your flux is nothing but your number of turns into armature current. Substitute here, your TE is proportional to number of turns into armature current means IA ka square. So for the first case, TE1 is proportional to total number of turns is T and armature current IA1 ka square. So let me take equation 2. Now in the case 2, you will be having the two coils which are connected in series like this, and these two coils, after that it is connected in parallel like this. So this is what said in the question. Done? So it is T by 4 turn, it was T by 4 turn, T by 4 turn and T by 4 turn. Let us take the armature current, in this case IA2. So since the coils are identical, it means that the current will divide equally in both parallel path. So therefore it will be IA2 whole divided by 2. Similarly here IA2 whole divided by 2. Done? Okay. So MMF in this case, MMF क्या होगा? Number of turns. See here, what is the number of turns here? T by 4. What is current which is flowing here? IA2 is for the second case, armature current for the second case whole divided by 2, because half is flowing. Now this is for the this coil. This amount of MMF is for this coil. You are having the coils which are connected in series. So therefore the same amount of flux will be generated. So instead of writing this one more time, let us multiply B with 2, because the MMF two coil are same. Done. So this is the EMF by this this series branch. You are having one more branch na, which is going to give you the same MMF. So instead of writing this one more time, let us multiply with 2. अरे ऐसे लिखते हैं ना, जैसे let us say 3 plus 3. This can also be written as 3 into 2. Instead of writing this, you can multiply with 2 if both the values are same. So यहाँ पे क्या मिलेगा जल्दी से देखें. It will be T IA2 whole divided by 2. ये समझ में आया? This is the MMF for the first coil. This is for the two coil, and this two is for the parallel combination. Okay. So EMF EA2 क्या होगा? Look at here. कहाँ गया? Yeah, EMF. So it will be let me write it directly. इसको लिख देते हैं directly. This is proportional to number of turns into IA2 whole divided by 2 into speed. कुछ नहीं किया, मैंने यहाँ पे MMF की जगह पे वो एक्सप्रेशन लिख दिया है, just like here. Replace this flux with MMF in this case. ठीक है? So in our case 2, this was the MMF. So EA2 is proportional to this MMF into speed for the second case, है ना? For the second case. So let it be third. Similarly, TE2, this is proportional to क्या होगा? This value T IA2 whole divided by 2. This is the flux or the MMF into armature current. देख लो एक बार यहाँ पे. The flux is proportional to MMF. Okay, so here this is the MMF. So this may also be written as or simplify as T IA2 का whole square divided by 2. Let it be equation 4. Okay, so one relation which was given in the question as your load torque is proportional to the square of the speed. Now under steady state, just a second, yeah, under steady state, your electromagnetic torque is proportional to your load torque. Then can I say TE2 divided by TE1 is equal to TL2 divided by TL1. Now TE2 ये कितना है? T, that is number of turns, IA2 का whole square whole divided by 2. TE1 ये कितना है? T IA1 का square, T IA1 का square. This is equal to, load torque is proportional to the speed, so it is N2 by N1 का whole square. Something is cancelling out over here. TT will be cancelled out, so we are left with IA2 का whole square divided by 2 IA1 का square. Let me see, equal to N2 by N1 का whole square. So from here N2 ये कितना होगा बताए तो? N2, or we can write N2, it will be equal to N1 times IA2 divided by root 2 IA1. So 3, 4 and let it be 5. I hope this is clear. क्या क्या बस इसको सिंप्लीफाई कर लिया, ठीक है. एंड नेक्स्ट वन कहाँ गया? इक्वेशन EMF. वी हैव यूज द टॉर्क वाला इक्वेशन, नाउ लेट अस यूज द EMF वाला इक्वेशन. सो EA2 डिवाइडेड बाय EA1 एंड दिस इज इक्वल टू, हाँ कहाँ गया EA1? T IA1 N1, T IA1 N1. And what about EA2? T IA2 by 2, T IA2 by 2 into N2. So ये क्या हो रहा है? TT will be cancelled out here, IA2 N2 whole divided by 2 times of IA1 N1. Now in the question indirectly the information about EMF is given. And what is that? In the question it was said that the losses are ignored. The losses are ignored. It means that the losses due to armature resistance is zero. What it implies? There is no armature resistance in the machine. So whenever the armature resistance is ignored, therefore your terminal voltage or EMF in both the cases will be same. So since, देखो नहीं समझे, this is EMF EA and this is terminal voltage VT. Here armature resistance is 0, RA is 0. So can I say VT is, or EA is equal to VT? So for the first case, for the second case, EA1 will be equal to V2. For the second case, EA2 will be equal to VT. So since VT is constant, so EMF will be fixed for all the cases. Therefore, this EA2 and EA1 both are equal. So let me write here, as losses are ignored, therefore EA2 will be equal to EA1. So from here we will going to get one relation, and what is that? So IA2 N2 whole is equal to 2 times of IA1 N1, और else N2 को हम लोग लिख सकते हैं क्या? होल डिवाइडेड बाई IA2, ये लिख सकते हैं. From here N2 will be equal to this expression. So let it be equation 6. Now since equation 5 and equation 6 are equal, equate equation 5 and 6. क्या मिलेगा? N1 IA2 root 2 IA1 is equal to 2 times of IA1 N1 whole divided by IA2. So your N1 will be cancelled out. So we are left with IA2 का square 2 root 2 into IA1 का square. So IA1 was given in the question. कितना था? 20 ampere. This was IA1. So IA2 will be equal to 2 root 2 का root 2 root 2 का root into IA1. IA1 was 20. So on solving this, IA2 will be equal to, let me write it, 33.635 ampere. 33.635 ampere. And the last one is the speed N2. Now from equation 6, N2 value will be equal to, क्या है? 2 times of IA1 N1, 2 into IA1 is 20. N1 कितना था? N1 was given in the question, na? Sorry. N1 was 600. N1 was 600. N1 was 600. And IA2 was 33.635. So this value is coming out to be a 713.542 RPM. So in which option it is given? It is given in option A and option D, which are the correct option for this question. Okay, any doubt, my dear friend? Any doubt in this question? See, this question can be easily solved without picking a pen. How? See, since we are changing the field coil, it means that we are changing the flux. We are changing the flux, and here the flux, here the coils are connected in parallel. Here the coils are connected in parallel. So we can say that whenever the coils are going to be in parallel, the overall current is going to be increase. Yes or no? अगर कोई भी coil को parallel में या कोई भी resistance को parallel में add कर रहे हैं, इसका मतलब क्या है? Resistance is going to be decreased and thereby current will going to increase. So in the second case, the current has to be greater than 20 ampere, which is given in only option A. So option A was the correct option. And this is the case of the flux weakening method. ये जो हमने पढ़ा ना अभी, this particular question is related to the flux weakening method. So whenever flux is going to be reduced, the speed is going to be increased. याद है? E is Vt minus Ia Ra. E is what? This is EMF, which is proportional to omega. So substitute here, or we can replace this as Km phi omega m. So substitute this value here, we'll get omega m as Vt minus Ia Ra whole divided by Km phi. Now since this is a case of flux weakening method, so flux is, if the flux is going to reduce, the speed is going to increase. So in the second case, the speed will be greater than 600 RPM, which is only given in option D. So in this manner, you can solve this question directly. Alright, so let us move on to the next question, which is this one. A 230 volt DC shunt motor has an armature resistance of 0.4 ohm and field resistance as 115 ohm. This motor drives a constant torque load and takes an armature current of 20 ampere at 100 rpm. If the motor speed is raised to 800 rpm to 1000 rpm, then the resistance that must be inserted in the shunt field circuit is. So since we are inserting the resistance in the field winding, it means that the current is reducing, है ना? If the current is reducing of the shunt winding, therefore the flux is going to be reduced and thereby the speed is going to increase. जो यहाँ पे दिख रहा है हमें. But my task is to calculate the shunt resistance such that we can achieve this 1000 rpm. तो वो resistance का value क्या होगा? So when external resistance was not added, so let me write the data. IA1 was 20 ampere, N1 was 800 rpm, and in this case the flux is proportional to the shunt current. As we know that the field current or shunt current both are same, which is responsible for the flux production. Done? Now for the simplicity, let me draw the diagram here. This is armature resistance. This is terminal voltage VT. And this is field resistance, which is RSH. This time external resistance is not added here. So plus minus EA1, IL1, IA1, and this is ISH1. Okay. So what is ISH1 in this case? VT whole divided by RSH. VT whole divided by RSH. Next, EMF. क्यों? I need to calculate this shunt resistance. For that, we require the EMF equation, because I'll be using this speed wala value. So we require the EMF equation. So what is EMF? EA1 equation, in this case EA1 will be equal to VT minus IA1 RA. Brush drop we need to ignore because it is not given in the question. IA1 कितना होगा? VT is given in the question as 230 minus IA1 is IL1 minus ISH1. इंटू RA. चलो देखते हैं दिया हुआ है कि नहीं क्वेश्चन में. 230 माइनस IL1 is given in the question or not? Yeah, it is given in the question. No, अच्छा, directly armature current was given, so 20 ampere. Okay, so it is given in the question directly. It was 20 ampere, and armature resistance was 0.4. तो ये कितना हो गया? EA1 it is equal to 222 volt. Okay, now what is ISH1? What is ISH1? This will be IL1 minus IA1. 22 minus IL1 was 20. Okay, it is also not given. It has to be given, otherwise it will be difficult to solve. Yeah, IL1 we can calculate. This is a motor. So IL1, Okay, just a second. We'll see whether IL1 is required to solve this question or not. Okay, we'll see. Meanwhile, let us calculate the ISH1, whatever value we are having. ISH1 will be equal to 230 divided by 114, so which is equal to 2 ampere. Okay, yeah, IL1 we can calculate. IL1 is equal to IA1 plus ISH1 KVL in that circuit, so it will be 22 ampere. Now, as EMF is proportional to flux into speed, this time flux is not constant because here resistance is going to change, so it will be EA2 proportional to ISH, or E is proportional to ISH into N, because flux is proportional to your shunt current. So EA2 is proportional to ISH2 into, sorry, EA1, this is a case 1 na, EA1 is proportional to ISH1 into N1. Let me take this as equation 1. Now let us include the external resistance. So let me add it. Let the resistance be Rg, this is RSH, this is ISH2, this is IA2 plus minus EA2, this is IL2 plus minus VT. Done? Okay, so ISH2 in this case क्या होगा? VT upon RSH plus RG. So this RG I need to calculate such that my speed becomes 1000 RPM. So VT is given in the question as 230, RSH is 115, RG I need to calculate. Done. Okay, what about EMF? EA2, VT 230 minus IA2 into RA. RA is given in the question. Yeah, RA is 0.4. Now this EMF is proportional to flux into speed. So this will be phi 2 into N2. Now since flux is proportional to your shunt current, so this is also be written as ISH2 into N2. So let it be equation 2. Okay. So from equation 1 and equation 2, one more thing. If we divide, we are going to have the unknown, two unknown, RG and current. Okay. All right. So see, 2 divided by equation 1. Let us first divide, and after that whatever things are unknown, we will move on to the next equation, which is the torque wala. So EA2 divided by EA1, ये कितना होगा यार? This will be 230 minus IA2 into 0.4 or 0.4 into IA2. Sorry, कहाँ गया? हाँ, 230 minus 0.4 into IA2 whole divided by 230. EA1 is 222 na, 222. So 222. So this is equal to not IA1, it is EA1. This is equal to ISH2 divided by ISH1 into N2 by Okay, so 230 minus 0.4 IA2 whole divided by 222. This is equal to ये कितना था 230 whole divided by RSH plus RG. Then ISH1 230 divided by 115 into N2 was 1000 and N1 was 800. Okay. So 230 minus 0.4 IA2 whole divided by 222. This is equal to 115 upon 115 plus RG into, this will be 10 by 8 or 5 by 4, both are same. So let me take this as equation 3. Now come to the torque wala equation. In the question it was given that the load torque is proportional to your or it is a constant, load torque is constant. Now under steady state your electromagnetic torque is proportional to your load torque or it is equal to the load torque. Now this is proportional to phi into armature current. So since it is proportional to L. Now since load torque is constant, can I say phi into Ia is constant? Because in the question load torque was constant. So phi 2 Ia2 is equal to phi 1 Ia1. So phi 2 by phi 1 is equal to Ia1 by Ia2. Now phi is proportional to the shunt current. So ISH2 divided by ISH1, this is equal to Ia1 divided by Ia2. Okay. ISH2 is 230 divided by 115 plus RG. Sorry, 230 RG plus 115 whole divided by 230 divided by 115, and this is equal to Ia1 by Ia2. Ia1 was given in the question, I guess. जरा देखिए, Ia1 was given in the question as 20 ampere. Ia1 was 20 ampere. So this is 20 by Ia2. So from here, what is Ia2? जल्दी से बताएं. What is Ia2? So 20 upon Ia2. This is equal to 230 divided by Rg plus 115 into 115 divided by 230. So this will be cancelled out. So 115 divided by Rg plus 115. So from here Ia2 will be equal to, क्या होगा? 20 upon 115 into Rg plus 115. कोई डाउट यहाँ पे? Ia2 will be equal to 20 upon 115 Rg plus 115. Now substitute this expression in this equation, equation 3, or sorry, in equation 3. Yeah, in this equation. Substitute Ia2 in equation 3. So let us see what we are getting. 230 minus 0.4, 230 minus 0.4 into Ia2 is 20 divided by 115 Rg plus 115 done. Whole divided by 222, which is EA1, 222, and this is equal to 115 divided by 115 plus RG, 115 plus RG into 5 by 4. Now here only one unknown is present, which is RG. So when you solve this, you will get RG value as, let me write it directly, RG value as 30.13 ohm. Okay, so I have left the solution part, like the rest thing, the calculation part to you. So only one unknown is present, so definitely we will get the RG value. So solve it, definitely you will have this value. All right. So I hope you have got the concept. Let us move on to the next problem, which is this. 400 volt DC series motor has armature resistance of 0.25. This is DC series motor. When running at 1200 RPM, it draws a current of 25 ampere. When a regulating resistance of 2.75 ohm is included in the armature circuit, it draws the current of 15 ampere. Find the speed and the ratio of two mechanical outputs. Assume that the flux with 15 ampere is 70% of that with 25 ampere. So terminal voltage is 400 volt. It is series motor, and armature resistance RA, this is 0.25 ohm. Now case 1, because you are going to have the two cases. When the flux was phi for the current of 25 ampere, and when the current is become 70% of phi for the current of 15 ampere. So you will be having the two cases. So the case 1, your armature current IA1 is 25 ampere and the speed is 1200 RPM. Now in this case, regulating resistance means the external resistance added in the series winding of the DC series motor. So when it was 0 ohm. Done. In the case 2, this time your regulating resistance is added, RG, it is 2.75 ohm, and your armature current now becomes 15 ampere. Now becomes 15 ampere. What else? If this is the cases, we need to find the speed N2 and ratio of two mechanical output. So the ratio, it means that let me see, yeah, EA2 IA2 whole divided by EA1 IA1. This we need to calculate. And one more information is given in the question, that flux at 15 ampere is 70% or 0.7 flux which was at 25 ampere. Okay? So here let us take phi for 25 ampere as phi, then let it be phi 1, then for the case 2, phi 2, which is phi 15 ampere. So from here we will get phi 2 as 0.75. Got the doubt? Do you have doubt? Any doubt in this question? So take this question as a homework. And please answer over the chat box, or once the session is going to be ended, please answer over the comment box. So I will go through each and every student answer. All right. So I'm as of now I'm not giving the answer over here. I want to check how many of you are going to solve this particular question. All right, so let us move on to the next one. Okay, all right. So we have completed the all concept related to the DC machine. Now we have arrived to the synchronous machine, which is again the chapter for the electrical. Okay. So what is the weightage? 2 to 4 marks, and these are the important topics. Okay. All right. Let us directly move to the question number 1 under the synchronous machine. All right. A 420 volt 50 Hz 3-phase synchronous machine operates at rated voltage and at leading power factor of 0.5. Shaft power is 20 kilowatt and excitation EMF is 390 volt. If per phase resistance is 0.5, the the synchronous reactance of the machine is. Neglect mechanical losses of the system. Okay, so before that we first know whether the given machine is a motor or a generator. So look at here, the power factor is leading. The power factor is leading. Then the power factor is leading. Then 2 cases is possible with respect to the voltages. Means when EMF is greater than terminal voltage Vt, this is the first case, and second case when EMF is less than Vt. In our question, here whenever EMF is greater than Vt under the leading case, then the machine is said to be motor. And in case of generator, for the leading power factor, EMF is always less than Vt. So in this question, 420, which is terminal voltage Vt, and EMF 390. So EMF is less than Vt. EMF is less than Vt. So this particular machine is what? Your generator. Okay. So here 390 is less than 420. So machine is generator. Done. So let me draw the diagram for simplicity. Here, let me draw here. Excess armature resistance, this is terminal voltage, and here you will be having the EMF. Means EF phasor is equal to magnitude EF at an angle del. And this is terminal voltage Vt phasor is equal to magnitude Vt at an angle 0 degree. And this is your current Ia phasor. Armature resistance Ra given in the question, per phase resistance is 0.5. Ra is 0.5 and this is J axis. So this axis I need to calculate. Okay, and we always we are already knowing that the electrical circuit always drawn on per phase manner. So the EMF and voltage and current all are per phase value. Okay, so Vt line, this is given as 420 volt. So Vt phase ये क्या हो जाएगा 420 volt divided by root 3. Okay, it is given as a star or delta, so nothing. So whenever no information is given about the type of connection, we will assume the star connected load. Sorry, star connection, not the load, star connection. So 420 divided by root 3. Similarly, EMF, EF line, this is 390 volt. So EF phase, so this is phase value, this is phase voltage. Similarly, 390 volt divided by root 3, this is also phase. What else? Armature resistance is 0.2. Shaft power PSH, this is 20 kilowatt. Okay, all right. So armature resistance we had already written as 0.5. How we can calculate? How we can calculate? Let me draw the shaft as well for the clear idea. how we can calculate the excess value? Okay, so in the question power factor is given as 0.5. So this power factor is internal power factor or the electrical power factor? It is the electrical power factor, means the angle between Vt and armature current. So cos phi, it is already given in the question as 0.5 lead. Okay, so phi is 60 degree. Done. Okay. So what else we can do? Apply KVL in this loop. Apply KVL in this loop. उससे भी कुछ नहीं होगा क्योंकि IA अननोन है. कैसे करें? Shaft power is given, so we can use this value shaft power. Okay, so this power is given, shaft power. So neglecting mechanical loss, I think it is already given in the question, na? Yeah, mechanical loss is 0 ohm. So your developed power or your shaft power is equal to developed power, which is 20 kilowatt. Okay, so here you will be having the mechanical loss, since it is already ignored. So whatever the power the shaft is generating, the same amount of power is developing here. Otherwise, if you are having the mechanical loss, na, that developed power will be would have been less than the 20 kilowatt. Since we have ignored this, so developed power is 20 kilowatt. So we have got the developed power. So developed power, P developed, will be equal to, so look at here, since we are talking about the real power or active power, so what are the real power component over here? Resistance will provide a real power or a loss, and this is the output side. So from here we will going to get the real power. So 3 times of Ia square armature resistance Ra. Why 3? Because of the 3 phase. This power is what? 3 phase power, plus root 3 times of Vt line voltage into IL. In this case, line current is armature current, Ia into cos phi. चलो देखो, 20 into 10 to the power 3, 3 into Ia is unknown, armature resistance is given in the question as 0.5, plus root 3 into line voltage is 420, yeah, 420, armature current is unknown, cos phi is 0.5. So from here we will getting one equation, which is 1.5 Ia square plus 363.73 Ia minus 20,000, which is equal to 0. Now from here we will be having the two values of Ia as 46.188 ampere and another one minus 288.675 ampere. Now since like see, this value is invalid because here current is negative, what it implies? The direction of current is reverse for this value of current. So if the direction of current is reverse, so the machine will act as a motor. Therefore it is invalid because machine is a generator. So we have got Ia value. Now we will be using the EMF equation to find our excess value. How? The EMF equation is equal to, in a machine, in a synchronous machine, this will be equal to Vt cos phi plus Ia Ra whole square plus Vt sin phi plus Ia excess whole square. So this equation is per phase equation. Now this is magnitude, so 390 divided by root 3, this is per phase EMF, is equal to Vt per phase 420 divided by root 3 cos phi is 0.5 plus Ia कितना किया हमने कैलकुलेट 46.188 RA is 0.5 RA is 0.5 whole square plus this part 420 divided by root 3 into sin phi. Sin phi is root over 1 minus cos square phi, means sin square theta plus cos square theta is 1 na. So from there we can get the sin phi, which is minus root 3 by 2 plus Ia is 46.188 into XS. Now you must be wondering, sir, why you have taken negative sign in the sin phi, not taken minus 0.5? Because my dear friend, this equation, the first one, this equation has been derived by considering the machine as a generator and power factor as a lagging. But suppose if the power factor is leading, then in the same equation we will take the power factor angle as negative for the leading power factor. Got the point? If the power factor is lagging, then we'll take phi as positive, but if the power factor becomes leading, then phi will be taken as negative. So cos of minus 60, यहाँ पे phi will be what? Minus 60 because of the lead, but I have ignored that one. So yeah, it is understood that in the expression of the EMF, phi should be taken as minus 60 because of the leading. So cos of minus 60 is what? Cos 60, which is 0.5 again. इसलिए मैंने यहाँ पे नहीं लिखा. But here sin of minus 60 is minus sin 60 or minus 0.5. Sorry, minus root 3 by 2. इसलिए negative sign आया यहाँ पे. So here you are having only one unknown. So solving it will get excess value as 8.288 ohm. ठीक है? It is given in option A. Okay, so what is the learning point over here? Note point basically. For leading power factor, the power factor angle will be negative. Done. So let us move on to the next problem. Okay, the effective resistance of a three-phase star connected 50 Hz to 2200 volt synchronous generator is 0.5 ohm per phase. On short circuit, a field current of 40 ampere gives the full load current of 200 ampere. An EMF line to line of 1100 volt is produced on open circuit with the same excitation. The regulation at full load 0.8 power factor lagging is. So basically this question is related to the voltage regulation. And what is that? Percentage voltage regulation. What is the formula? Magnitude of EMF minus magnitude of terminal voltage divided by magnitude of terminal voltage into 100%. If you are taking any one of the parameter as a line, then automatically the second or the remaining parameter has to be taken as a line. If one is phase, the other has to be phase as well. Okay, chalo. Let us see what value are given in the question. So terminal voltage is given as 2200. So this is line voltage. So let me take the line voltages directly. So 2200 divided by 2200 into 100%. Only unknown is EMF. So how we can calculate EMF? The same expression. EMF, this is what, motor or generator? Okay, yeah, this is generator. So this is Vt cos phi plus IARA whole square plus Vt sin phi plus IA XS whole square. So this is your per phase EMF, per phase EMF. Vt is given in the question, which is 2200 divided by root 3 per phase voltage. Power factor is 0.8. Armature current is given. Yeah, it is 200 ampere. What is unknown? Armature resistance is given somewhere. Yeah, armature resistance is 0.5. So only unknown is this excess. If I have excess value, I will be having my answer. So कैसे calculate करेंगे? कैसे calculate करेंगे? We'll take the help of this statement. Okay, so look at here. Zs, this is equal to a synchronous impedance. Zs is equal to terminal voltage under open circuit, armature current under short circuit, but at the same field current. But at the same field current. Now, since impedance is per phase, impedance is always a per phase, therefore terminal voltage and armature current are also per phase. If you look at here, your full load current is 200 ampere at 40 ampere of field current. It means at IF equal to 40 ampere, your armature current under short circuit, which is rated current basically. So let me write simply IA. This is 200 ampere. Na? Let me check. 200 ampere. Now on the same field current or on the same excitation, both are same. Field current and excitation both are same. You are having the open circuit voltage as 1100. It means that on the same field current, your terminal voltage is 1100 volt under open circuit. But this is your line voltage. As I told you, this is per phase, so we require per phase value. Since it is a star connection, so it will be 1100 by root 3 volt. So this is phase. Substitute here Zs is equal to, since both are on same IF, so 1100 divided by root 3, substitute here, whole divided by 200. So you will get Zs, just a second, Zs as 3.175 ohm. Now what is Zs? Zs is Ra plus jXs. This is magnitude. So take the magnitude of it. It will be Zs square equal to Ra square plus XS square. Zs square means 3.175 ka whole square. Ra is 0.5 and XS is XS whole square. So from here, what is XS? XS is 3.175 ka square minus 0.5 ka square. So let me write the value directly. 3.1357 ohm. So this is your XS value. So we have all the information. Substitute here in XS. So EF is equal to root over. So Vt is, just a second, Vt is 2200 by root 3, 2200 by root 3 into cos phi is 0.8 plus Ia is 200 into Ra is 0.5. So Vt cos phi plus Ia Ra plus Vt sin phi. So 2200 divided by root 3 into sin phi means 0.6 plus Ia XS 200 into XS is 3.1357. Sorry, कितना है? 3.1357. 3.1357 का whole square. So this EMF is coming out to be as 1782.06 volt. But my dear friend, this is line or phase? This is your phase value. This is your phase value, because this equation is for per phase. So what is line? Multiply it with √3. So this will become line voltage. Connection was star, na? So इसीलिए there will be a change by a factor of √3 from phase to line. All right. So we have all the values. So percentage voltage regulation is equal to EF, which is √3 into 1782.06 minus VT, which is 2200 divided by 2200 into 100%. So on solving this, we'll get the answer as 40.3%. Okay. So the correct answer for this question is option C. Option C. All right. So move on to the next question. This question is related to the droop characteristics. Okay. A two generator rated 500 megawatt and 600 megawatt are operating in parallel. The droop characteristic of this generator are 4% and 5% respectively with respect to the full load. It is very important line, with respect to the full load. Assuming that the generator are operating at 60 Hz at no load, how a load of 1100 megawatt should be shared between them and the system frequency at this load? So here, when the load is 1100 megawatt, then what should be the load shared by the two generator, and when they are saying this particular load, at what frequency they are operating? Done. So this we need to find in the question. Now what do you mean by drop here? Not drop, droop. What do you mean by droop? Whenever a load is given in the system, then the frequency, then the system frequency is going to be reduced. एक जैसे होता है ना कि बाइक पे अगर आप ज़्यादा पर्सन को बैठाओगे तो बाइक की स्पीड क्या होती है, धीरे धीरे करके रिड्यूस हो जाती है ऑटोमेटिकली. अरे भैया जैसे मान लो 0 to लाइक आपको 10 किलोमीटर जाना है, इफ यू आर अ सिंगल राइडर देन यू कैन रीच वेरी लाइक फास्टली ना व्हेन कंपेयर्ड विद अ पिलियन वन. अगर दो लोग बैठे होंगे तो थोड़ा ज़्यादा टाइम लगेगा एट द सेम स्पीड. नहीं, सेम स्पीड पे जाओगे तो सेम ही टाइम लगेगा ना फॉर द सेम डिस्टेंस. Okay, so what I mean to say, if a load or a weight is given in the question, then the performance is going to be degraded or your system frequency is going to be reduced. This is nothing but your droop. Okay. See, no load frequency is given in the question. Now let us find the full load frequency. Full load frequency means when the load is full load. This is the full load for the generator 1 and this is the full load value for the generator 2. So when this load was given in the question, then what should be the frequency at full load, that we need to determine. So look at here, 4% for this particular load and 5% for this particular load is given. So droop, what is the formula? Or percentage droop, what is the formula? It is change in frequency from no load to full load. In the denominator, either full load can become or no load can become. So it depends on how the examiner is defining the droop. मैंने बोला यहाँ डिनोमिनेटर में फुल लोड भी आ सकता है या फिर नो लोड भी आ सकता है. ये डिपेंड करता है कि एग्जामिनर यहाँ पे क्या दे रहा है. सिंस दिस ड्रूप इज रिलेटेड टू द full load, so in denominator it will be FL. So this is the definition of the droop. Okay, so for the machine 1, for machine 1, 4% droop, which is equal to, no load frequency is 60, है ना, no load frequency is 60 minus F full load 1, F full load 1 into 100%. So let me write it directly. F frequency at full load, this value is 57.7 hertz. And for machine 2, it was 6%, no load frequency is 60. For the machine 2, the frequency is same, na? F full load 2 divided by F full load 2 into 100%. So from here, F full load 2 is equal to 57.143 hertz. Okay. Now let us draw the droop diagram. So here this is a system frequency axis, frequency in hertz, and this is the power axis in megawatt. So let us take this side, the right hand side is the generator 1, and this left hand side, this axis is generator 2. Okay? Please do not think that in the generator 1 the power here is positive, and for generator 1 the power will be negative. No. So this side I am writing the generator 1 power, and this side I am writing the generator 2 power. Okay, so let us take the frequency, no load frequency as 60 hertz, which is already given in the question. This is 60. Now generator 2 have a droop as 4%. So this is the droop. And generator 2 has a droop as 6%. Means the slope is higher for the generator 2 when it is compared with the generator 1. मैं generator 1 किसको बोल रहा हूँ? 500 को, the lower value, and generator 2 600 को. ठीक है? Okay. So this is 0 megawatt power, and here the power is increasing for generator 1, and here generator 2 ka power is increasing in this side. Now when the load is full load, the frequency is, when the load is full load, what is full load for the generator 1? It was 500 megawatt. At this megawatt, what was the frequency for the generator 1? It was 57.7 hertz for the generator 1. In the same case, or in the same manner, not in the same case, in the same manner for the generator 2, suppose if the load would have been a full load, then the full load frequency for the generator 2 would have been 57.143. So full load was 100 megawatt. Done. But I need to calculate the load which is supplied by the generator 1 and generator 2. So what is that load? Let me write here. Suppose generator 1 is supplying the real power as P1, and generator 2 is supplying the real power as P2. So this total power is 1100 megawatt. So let it be equation 1. Let it be equation. So whenever the generators are supplying the power, then both generator will operate at the same frequency. So let us take that frequency. Let me change the color. Let me take the frequency here at which they are operating as Fn. So at this frequency they are operating. Now at this frequency, Now at this frequency, they are delivering the power as P1 and generator 2 is delivering the power as P2. That is what I need to calculate. So this is P1 and this is P2. So I need to calculate this P1, P2 and this new frequency. So look at here. See this triangle A, B, C, A, B dash and C dash. So these are similar because their angles are same. So tan theta AB by BC, AB by BC is equal to AB dash divided by B dash C dash. है कि नहीं? Because both triangle are similar. So for generator 1, can I say AB by BC is equal to AB dash divided by B dash C dash. So ये कितना होगा? 60 minus AB is 60 minus Fn. This power is P1. This is equal to AB dash 60 minus 57.7, 60 minus 57.7 whole divided by B dash C dash, which is from here to here 500. So this implies P1 value is 60 minus Fn, 60 minus 57.7 into 500, let it be equation 2. Now for generator 2, look at here, for generator 2, this triangle, small one, is similar to this bigger triangle. Okay, so let me take C double dash and here B double dash. And this to be क्या ले ले इसको? D ले लेते हैं चलो. ABD और AB by BD, AB by BD है कि नहीं? This triangle AB by BD is equal to AB double dash, AB double dash divided by B double dash C double dash. देख लो एक बार. This triangle AB by BD equal to AB double dash divided by B double dash C double dash. So ये कितना होगा? AB is 60 minus Fn divided by P2 is equal to 60 minus 57.143 whole divided by 600. So from here P2 value is equal to 60 minus Fn, 60 minus 57.143 into 600. So let it be equation 3. Now substituting equation 2 and equation 3 in equation 1. Substituting equation 2 and 3 in equation 1. What we are going to get? See, 60 minus Fn divided by 60 minus 57.7 into 500. This is P1 value. 60 minus Fn divided by 60 minus 57.143. Let me check. 57.143 into 600, and this is equal to 1100 value. So I have substituted in equation 1. only one unknown is present, which is Fn. So on solving this, we'll get Fn value as, let me see here, Fn value as 57.42 hertz. So we have got the Fn value. Now we are left with P1 and P2. Substitute this Fn in equation 2. So we'll get P1 value. So what is equation 2? P1. See here, only unknown is Fn, but we have got the Fn value like this. Substitute this value here. You will get P1 as 559.5 megawatt. Similarly, from equation 3, P2 value is equal to, either substitute this Fn here, or else we can do total power, which is P minus P1. क्यों भैया ऐसा क्यों? Because P1 plus P2 is 1100. We have got P1, so P2 value will be 1100 minus P1. So 1100, P1 is 559.5. So this is equal to 540.5 megawatt. So in which option it is given? So 559.5, 540.5 and 57.42. So option A is the correct option for this question. Any doubt? Clear? See, at 500 for the generator 1, at 500 what is the frequency? 57.7. But what actually generator 1 is delivering? It is delivering more than its capability or the capacity. 559.5 means यहाँ कहीं आएगा 559.5. Therefore, frequency will reduce further. वो यहाँ कहीं आता. ठीक है? So yeah, it is evident that whenever you are trying to increase the power, if you are trying to increase the load, then frequency is going to reduce. All right. So let us move on to the next problem. Again, it is MSQ type. Two 550 kVA alternator operate in parallel to supply the following loads. First load is 250 kilowatt at 0.6 power factor lagging. Second load is 100 kilowatt at 0.5 power factor leading. One machine is supplying 200 kilowatt at 0.9 power factor lagging. The power factor of other machine is, okay, क्या होगा? See, basically this question is related to the parallel operation of synchronous machine or parallel operation of the synchronous generator. Synchronous generator is alternator. Okay, so the symmetric diagram I have already drawn over here. This is machine 1. Let me use different color. This is generator 1, or you can say machine 1, and this is generator 2 or machine 2. For the generator 1, like for one machine, it is given the power as 200 kilowatt, 0.9 power factor lagging. So 0.9 lag. Then the two load, the first load is 250 kilowatt at 0.6 power factor. So 250 kilowatt at 0.6 lag. And the another load is 100 kilowatt at 0.8 power factor leading. 100 kilowatt at 0.5 leading. So let this be load 1 and here load 2. And what is this line? This line is RYB or ABC, 3-phase line. Done. And if you see, the two generators are connected in parallel and these two are supplying the load. Now how we can approach for this solution? How we can approach for the solution? A basic rule. Whatever power is generating, if the machine is lossless, assuming the machine is lossless, whatever power is generating, those will be delivered directly to the load. So my dear friend, in this case, let us take the complex power generated by the generator 1 or machine 1 is S1 conjugate. S1 conjugate. So this is the complex power generated by the generator 1. Similarly, the complex power supplied by the generator 2 is S2. So this 2 power is equal to the load power SL1 conjugate and SL2 conjugate. क्या बोला मैंने? मैंने ये बोला S1 conjugate plus S2 conjugate is equal to S load 1 conjugate plus S load 2 conjugate. So this is what? P plus JQ form. It is not the apparent power. Apparent power is magnitude root over P square plus Q square. But here this is in complex form, P plus JQ form. Alright. So let it be equation 1. Alright. So see, S1, let me change the color. S1 is P1, sorry, S1 conjugate is P1 plus JQ1. SL1 is PL1 plus JQL1. Conjugate basically. SL2 conjugate, this is PL2 minus JQL2. Why minus? Because the load 2 is leading. Load 2 is leading. For the leading, complex power angle is negative. For lagging, complex power angle will be positive. तो यहाँ पे देखो, plus is for lagging, minus is for leading. Okay, so my task is to calculate this S1 conjugate. So कैसे calculate करेंगे? How we can calculate? See, as we know that S1 or S, sorry, real power P is S into cos phi. यही लिखते हैं ना? Real power is S into cos phi, where S is what? Apparent power, root over P ka square plus Q ka square. Now for the generator 1, real power is given 200 kilowatt. Let it be S1 into cos phi. So it is 0.9. Cos phi is 0.9. So ये कितना आ रहा है? S1. So let me write it directly. S1 is 222.22 kVA. So this is your apparent power. Now what is complex power? It will be 222.22 at an angle. Angle will be positive because of the lagging. Because of the lagging. So cos inverse 0.9 कितना होगा? It will be 25.842 kVA. 842 kVA. क्या ये समझ में आया सबको? Everybody, it is clear. This is your apparent power or the magnitude of S1, and this is angle of S1. Angle will be positive for the lagging and it will be negative for the leading. So using the same concept, we'll get SL1 conjugate, means for the load 1. See, real power is given, power factor is given. For load 2, real power is given, power factor is given. So using the same concept, we'll get SL1 conjugate as 416.67. Since power factor is lagging, so plus 53.13 degree kVA. Similarly, SL2 conjugate, this will be equal to 200 at an angle minus 60 degree. See, cos inverse 0.5, 60 degree, but due to leading, we need to use negative sign. Now from equation 1, your S2 conjugate is equal to 416.67 at an angle 53.13 degree plus SL2 200 at an angle minus 60 degree minus S1 conjugate, which is 222.22 at an angle 25.842 degree. So this value is coming out to be as 162.8 at an angle 22.87 degree. This is S2 conjugate, but we are supposed to calculate power factor and the nature of power factor, whether leading or lagging. Now see, your power factor, here angle is what? For the complex power, what is the angle? Angle is positive. It means that it is operating as lagging. So option D is correct. But what is power factor? So cos phi, which is cos 22.87 for the generator 2 or alternator 2. So this is equal to 0.92. As this angle is positive, therefore it is lag. So option A and option D both are correct. Okay. So I hope you have got the concept. So please remember how we can how we can write on what basis we can write the positive angle and negative angle. Always remember the complex power will have the positive angle for lagging and it will be negative for the leading power factor. Okay, let us move on to the next one. A 400 volt 3-phase delta connected, a 400 volt 3-phase delta connected synchronous motor has an excitation EMF of 600 volt and synchronous impedance per phase of 0.3 plus J6 ohm. Calculate the efficiency and power factor when the machine is developing maximum gross mechanical power. Assume friction, windage and core loss as 2.4 kilowatt. Okay, so this is what delta connection and synchronous motor. So let me draw the diagram. Let me write here. Okay. So EF phasor, which is EF at an angle minus del. Why minus del? Because it is a motor. For the motor, del is negative and for generator the del is positive. Del is load angle. This is VT phasor, which is VT at an angle 0 degree. And since this is a motor, so current will come from terminal and it will enter into the shaft or the alternator, or the armature, not the alternator, armature. This is your armature resistance RA, synchronous reactance, which is JXS. I hope this is given in the question. 0.3 and J6. This is 0.3 and this is J6. Okay, so your EMF is 600. So since it is a delta connection and we know that in the delta, phase and line voltage both are same. So therefore, let me change the color, just a second. Therefore, it is 400 at an angle 0 degree, and this is 600 at an angle minus del. Alright, so this information is given in the question. And also one more thing, losses, friction, windage and core loss, it means that it is a rotational loss. So P rotational, this is given as 2.4 kilowatt. So my task is to calculate the efficiency and power factor. So efficiency and power factor that we need to calculate at developing maximum gross mechanical power. What it means? Means P develop, it has to be maximum. So this is your input power and this is your developed power. Here it is as input to the motor, and here the power is developing. So S developed. Okay, so first kahan gaya? Okay, just a second, let me complete this figure. I have left one portion of it. Let me make a shaft. Okay, this is our shaft. Okay, done. All right, so first we need to identify that what will be the condition such that P develop or the developed power will become maximum. So what I will do, first I will derive the S develop. So see how I can write or how I can find S develop is equal to, means the developed power is equal to. So this is the armature, so here power is going to be developed. So this is input and this is developed. So what is EMF or voltage here? EF phasor into IA phasor, but conjugate, because this is the complex power. Okay, always find the complex power, not the simple one, because whatever power we are developing over here is a complex power. And how we can find? By taking conjugate either in IF or in IA, not on both. Chalo. So EF is EF at an angle minus del. And what is IA? Apply VL in this loop, KVL in this loop. We'll get VT at an angle 0 degree minus EF at an angle minus del whole divided by, this value is ZS. Hey, ZS is RA plus JXS. So let me write magnitude of ZS at an angle theta s, but iska conjugate. So let me see, this is equal to EF VT divided by magnitude of ZS at an angle theta s minus del minus EF square whole divided by ZS at an angle theta s. Done. Now this S develop is nothing but P develop plus J Q develop. This is a complex power. And we know that P develop or the real power is a function of cos, whereas reactive power is a function of sin. लिखते हैं ना, P equal to S into cos phi, Q is S into sin phi. Similarly here, P develop is what? Take the cos term. It will be EF VT by ZS cos of theta s minus del minus EF square by ZS cos theta s. So this is the developed power or the real power which is developing in the armature. Now on what condition this power is going to be maximum? See, what is the independent quantity? Independent quantity is del. In this case, independent quantity is del. So, differentiating developed power with respect to del, and when you equate it to 0, we'll get one condition, and that condition is what? Del equal to theta s. So, differentiate with respect to del, you will get one expression where del becomes equal to theta s. So, at this condition, your power is going to be maximum. So, P develop maximum, substitute this value in this expression such that this becomes maximum. So, EF Vt by Zs, EF Vt by Zs minus, since these two are same na, so it will be cos 0 is 1, minus EF square divided by Zs into cos theta s. What is cos theta s? See, the angle of this is what? Angle of this is what? Your theta s. यानी मैं ये कहना चाह रहा हूँ tan theta s is excess by RA. Tan theta s is excess by RA. Internal impedance angle. So, from here, what is cos theta s? Cos theta s is RA divided by Zs. Done. So, this is magnitude, na? This is magnitude. So, yes, we have got the developed power which is going to be maximum. So, this is your expression. Please remember. If you remember, you could have directly written this particular equation. Otherwise, if you are not knowing this, we can easily derive in the exam. Okay, so we have got the expression. So, what is the what is the value of this theta s? Anybody? What is the value of this theta s? So, this theta s is equal to tan inverse. XS is 6 and RA is 0.3, 6 by 0.3. So, this is equal to this value is 87.1376. 87.1376. I hope this is visible to you. 87.1376. So, we have all the values. We have EF value, VT value, Zs is magnitude. So, इसका magnitude क्या होगा? Root over 6 का square plus 0.3 का square. So, substitute here. EF is 600, VT is 400. So, 600 into 400. Magnitude of Zs, I have the value which is 6.0075 minus EF is 600 का square whole divided by, see this is Zs का square na, so 6.0075 का whole square into RA is 0.3. So, this value is coming out to be as 110.985 kilowatt. Done. So, this amount of power is developing in the machine under the maximum developed power. So, I think power factor we need to calculate and efficiency. Now, for efficiency under the maximum developed power, what we require? We require the output and we require the input. So, how to get the output? See, we have got the developed power which is this value. And here at this shaft, you are having the losses as friction, windage and core loss, which is basically rotational loss and which is given in the question. So, your shaft power or output power, remember the power flow diagram of the DC motor. Power flow diagram is what? Universal, because the structure of the DC machine, induction machine, synchronous machine are same. Therefore, the power flow diagram are same. So, when you remove the rotational loss from the developed power under the maximum condition, you will get the shaft power, which is equal to, let me write it here directly, this minus this, we will get 108.585 kilowatt. 108.585 kilowatt. So we have got the your output power. Now for efficiency, we require input power as well. What is input power? √3 times of VT, this is line voltage, into IAL, line current, into cos of angle between VT line and IA line. Sorry, VT phase and IA phase. So कैसे करेंगे? VT line is given in the question 400. IA is unknown, I guess. IA is not given in the question, na? IA is unknown and power factor is unknown. So my task is to calculate IA. How I can calculate IA? How I can calculate IA? How I can calculate IA? See, VT is, please find the difference. Here these parameters are line, and when you are taking 3, na, the parameters becomes phase. So this phase voltage, phase current, and cos of angle between the phase voltage and phase current, which is basically what? Power factor angle. But my question is how we can calculate this IA value. Now apply KVL in this loop. क्या मिलेगा IA? KVL in the circuit. So IA is equal to VT at an angle 0 degree minus EF at an angle minus del. But please remember, under the maximum condition, divided by magnitude of Zs at an angle theta s. So this is your IA value. Now here del is what? Theta s. Del is what? Theta s, means these two angles are same. Substitute all the values. We know all the values. VT 400, EF 600, del or theta s is 87.1376 degree, and Zs is what? Magnitude of Zs here. So on solving this, you will get IA as 117.236 at an angle minus 28.83 degree ampere. So this is your phase current which is flowing in the synchronous motor. Now in this equation, P in, input power, this is equal to 3 times of per phase voltage, which is 400, per phase current, which is 117.236 into cos of angle between voltage and current. So since terminal voltage has a reference of 0 degree and IA has an angle of minus 28.83. So what is the angle difference? 28.83. So this value is 123.2426 kilowatt. Done. So percentage efficiency is equal to output power by input power into 100. So we have all the values. P naught is here, P in is here. Substitute in this expression, we'll get percentage efficiency as 88.1067%. Any doubt? Any doubt in this question? Clear hai? So we have calculated the efficiency for the machine and as well as power factor. So power factor is what? Power factor. This is your power factor, cos of 28.83 degree. So this value, let me calculate it. Cos of 28.83. So this is 0.876. It is lagging or leading? It is lagging or leading? Voltage is Vt at an angle 0. Current is 117.236 at an angle of minus 28.83. So current is lagging the voltage. So therefore, it is lagging power factor. So these two are your values. So I hope you have got the solution for this particular question. I know the question is somewhat lengthy. It is difficult to understand, but my dear friend, you will not going to get the complete question. You will going to get some part from this question basically. Some part of this question. Okay, so try to learn the basic. Please do not by heart the things, because by hearting the things will never save you in the exam. Not in the GATE exam only, in any exam. If you going to by heart the things, or else if you are not going to understand the concept, it will be very difficult for us to crack the exam with a good marks. Alright, so I am here to basically to discuss the concept, how to approach the particular solution or the particular question. Okay, so let us come to the last question that we are having. This. A three-phase synchronous motor has 80% synchronous reactance and negligible resistance. When connected to bus bar at rated voltage and excitation adjusted for EMF of 120%. The machine draws an input kVA of 100%. Find the mechanical power delivered by the motor, neglecting all the losses. If for the same load on the motor, the excitation is reduced to generate an EMF of 100%, what would be the input kVA? What would be the input kVA? Okay. Let us discuss the last problem. Okay. Before that, let me write the data. So it is synchronous motor, three-phase, synchronous reactance XS is 80%, means 0.8 per unit. It means that this question is related to per unit. Next, negligible armature resistance means RA is 0. When connected to bus bar at rated voltage, so VT is 1 per unit. And the excitation adjusted for an EMF, EF, is 1.2 per unit. The machine draws an input kVA of 100%. It means that S, this is 100% is what? It is complex power or apparent power. Apparent power means magnitude. So it is apparent power. Always the complex power is given in complex manner. P plus JQ, like 1 plus J2, 1 plus J3, 4 plus J3, so on and so forth. So this is 100% means 1 per unit. Find the mechanical power developed, okay, by the motor. So we need to calculate P mechanical or P developed, both are same, by the motor, neglecting all the losses. If for the same load on the motor, if for the same load means for same load for same load, so this is the load that we are having from the first case. For the same load, we need to calculate the input kVA. So let me write input kVA क्या ले ले, SX ले लेते हैं, चलो कहाँ गया. If for the same load on the motor, excitation EMF is reduced to generate an EMF of 100%, so 1 pu. I hope the question is clear. So in the first data, EMF, VT, S, RA, XS are given. We need to calculate mechanical power or developed power. And in the second part, for the same load, when the excitation is changed to 1 per unit, for that we need to calculate the SX value, or let me write simply S. So let it be S1, let it be S2, EF1, let it be EF2. Okay, all right. So look at here. For an input kVA of 100%, it means that S is equal to VT into IA. Okay, देखो मेरे कहने का मतलब S equal to √3 VT into IA ये लिखते हैं ना. So this is in their unit values. So sorry, unit expression means this voltage is in their unit, IA is in their unit. But when you write in in per unit manner na, there will be no factors of √3, because per unit is what? S actual divided by S base. So it means that √3 VT actual into IA actual divided by √3 into VT base into IA base. So if you look at here, your power in per unit is free from √3 factor. So this will become VT per unit into IA per unit, where per unit is actual by base. Got the point? So this is in per unit. Please remember, this is in per unit, because all the values are given in per unit. So let me inbox this. Okay, all right. So this is 100%, VT is rated, so IA. So IA is what? 1 per unit. IA is 1 per unit. Now my dear friend, what is the power factor? Means whether your synchronous machine is overexcited, underexcited, or normal excited. To judge this, we require two information: EMF value and the terminal voltage. See, your EMF is greater than terminal voltage, which is 1. EMF is 1.2. EMF is 1.2 per unit, which is greater than terminal voltage, which is 1 per unit. It means that excitation is more than the terminal voltage, and this is what synchronous motor. It means that synchronous motor is overexcited. So whenever synchronous motor is overexcited, it is operating at leading power factor. This is just a basics of your synchronous machine. Okay? In this manner, we can judge if you are having EMF and terminal voltage. So the EMF equation, EF is equal to root over VT cos phi minus IARA whole square. Please do not write plus, because plus we are using for the generator, plus VT sin phi minus IA XS. Okay, so see, power factor is given in the question or not? So it is not given, but we can calculate very easily. EF is 1.2. Sorry, let me write here. EF is 1.2. This is equal to root over. VT is 1 cos phi, 1 into cos phi, minus IA RA. RA is negligible, na? So from the first parenthesis we are getting cos phi ka square, plus VT sin phi means 1 into sin phi. So here sin phi will come, minus IA XS. IA is 1. We had calculated, na? And XS is 0.8. So XS is 0.8 ka whole square. So we are getting cos square phi or cos phi ka square plus sin phi minus 0.8 ka whole square, which is equal to 1.2 ka whole square. So look at here, cos square phi, this is a minus b ka whole square. So sin square phi minus 2 into sin phi into 0.8. So let me write here 1.6 sin phi plus 0.8 ka square, which is equal to 1.2 ka square. So this is what? Sin square phi cos square phi, it is 1. So from here 1 minus 1.6 sin phi plus 0.8 ka square, which is equal to 1.2 ka square, sorry, 1.2 ka square. On solving this equation, we'll get sin phi as 0.125, 0.125. So this implies cos phi, which is equal to root over 1 minus sin square phi. So this is equal to, substitute this value here, we'll get cos phi as 0.9922 lead. Why lead? As I told you, it is overexcited, so leading power factor. Okay. So mechanical power which is developing is equal to VT into IA cos phi. But you must be thinking that, or you must be wondering that, sir, mechanical power in case of motor, it is EF and IA, na? Then why you are writing VT? As we had discussed in the last problem, kahan gaya? Yeah. See, the mechanical developed power is EF into IA, na? जो यहाँ लिखा हुआ था. Then why you are writing VT into IA? Because your armature resistance is negligible in the question. When it is neglected, so there will be no loss in the machine. So whatever power is developing over here is same as that of the terminal power. इसलिए मैं वहाँ पे लिखा हूँ VT into IA into cos phi. Okay, so VT was 1, IA is 1, and cos phi is 0.9922. 0.9922. So your mechanical power, or which is also a developed power, is equal to 0.9922 per unit. Done. So we have got the developed power. Now our first part is completed. Now let us discuss the second part. Means for the same load, if EMF is changed to 1 per unit, what is the input kVA? So for the same load, when armature resistance is neglected, we can directly write EF VT by XS sin del equal to P. Okay, so here P is P input or P developed when armature resistance. Okay, so since it is a case, here I have taken EF2 for this portion. So let me write EF2 VT XS sin del, and this P, let me write P only. So EF2 is 1, VT is 1, XS is 0.8 into sine del, which is equal to P for the same load, means 0.9922. 0.9922. So from here del value that we are getting as 52.54 degree. Done. Now my dear friend, what is S2? We have written S2 na. What is S2? S2 is VT into IA2. यही लिखा था ना in per unit. Input kVA is VT into I. So since VT is same for both the cases and VT is rated value, so it is 1 into IA2, which is IA2. So my task is to calculate this IA2. IA2 is unknown. If I get IA2 value which is equal to the input kVA. So how I can calculate IA2? By using the KVL equation in the motor. So I can write EF at an angle minus del is equal to VT at an angle 0 degree minus IA at an angle phi ZS at an angle theta s. यही लिखते हैं ना. So look at here, IA ZS at an angle, in multiplication angles are added, phi plus theta s. This is equal to VT at an angle 0 minus EF at an angle minus del. Now from the basics of the parallelogram theorem, like suppose you are having one vector A and another vector as B, and angle between these two vectors as theta. Let me write theta. Means this is one vector A, this is one vector B, and angle between these two is theta. Then the resultant R will be equal to root over A square plus B square plus 2 into AB cos of angle between these two, which is theta. Using the same concept, what we can write for the right hand side equation? We can write, just a second, okay, so we can write, see, take the magnitude, because this is what? This is magnitude na, resultant, this is magnitude. So take the magnitude on both sides. तो इसका magnitude क्या होगा? This magnitude is IA Z. अरे भैया इसका magnitude क्या होगा? P at an angle theta. What will be the magnitude? Magnitude will be P only na. So right hand side का magnitude is IA ZS, which is equal to root over VT square plus EF square minus 2 VT EF cos del. Cos del, because of this minus. Without B is minus EF and A is VT. And what is the angle difference between this VT and EF? It is del, angle difference, it is del. So when you put B as minus EF, so it will become minus. Minus will come here. ठीक है? चलो. So ZS is given in the question. ZS is what? Root over RA का square plus XS का square. Since RA is 0, which is given in the question, so for this case ZS is equal to XS. So this is IA2. Since we are dealing with the second case, so it will be IA2 into XS, which is equal to root over VT square plus EF square minus 2 VT EF cos del. So IA2 is unknown, XS is 0.8 given, which was given in the question. VT is the rated voltage 1 ka square. EF is 100%, which is again 1 ka square, minus 2 into 1 into 1 into cos del. This is your del value, cos 52.54 degree. So from here IA2, we are getting IA2 as 1.1065 per unit. So in the same manner, which implies S2, which was IA2, we had discussed a couple of minutes back. IA2 is 1.1065 per unit, or in terms of percentage, 110.65%. Okay, so for the same load, if EMF is reduced, then your input kVA is increased by 10.65%. All right, so in this manner, we have completed all the questions which are important with respect to the GATE exam. Okay, I have shown you the important topic in the part 1, as well as this is part 2, in the part 2. So you need to be more focused on those particular topics. Since we are hardly left with the 60 days, like less than 60 days. So we should be more focusing on the revision part, on the problem solving, on the test series, on the practicing the questions, scaling up the problem solving ability, and so on and so forth. Okay, so you can do by taking this practice problem. So this is your practice problem. Again, please do share the answer over the comment box. All right. So again, let me take a couple of minutes of yours. The PDF of this session will be shared to our Telegram group. The link is given in the description box, or else you can visit to this ID. And what features you are going to get in our Telegram group at free of cost? Free YTube lecture, free lecture PDF, important updates on seminar and webinar, PSUs and other government job notification, expert session on important topics, and daily quiz, and many more. All right. And the last one is, since I had given a lot of time for such question, I have given my sweat, not the blood, my sweat. So such kind of thing we are also delivering. We are delivering basically in our online classes or even in the offline classes. So those who are opting for GATE 25, those who want to opt for GATE 25 or for GATE 26, we are having the live online program for you, and in that we are giving such this kind of features: 800 plus hours of live classes with live interaction, theory book, exercise book of all the subjects, along with 30 plus years of GATE question banks with video solution, mark my word, with video solution, and 12 personalized one-to-one mentorship session, and 130 plus online test with video solution, and many more. And if you want to have the counseling, then you can book your free counseling session by calling on this particular number, or else the link is given in the description box. On that you can fill a form so that our counseling team will get back to you. All right. So with this we have completed the electrical machine GATE score booster. I hope it will definitely go like if you're going to watch this particular session one more time or two more time, until and unless you get master of the electrical machine, definitely at one point you will see a great change in yourself. So let me end the session over here. Please do prepare well. Please practice a lot of problem. Please revise the thing more number of time, like 1, 2, 3. And whenever you are having any sort of doubt, please feel free to comment on the comment box, like doubt related to the machine, not the other thing. Okay? So all the very best for your GATE exam and the future. Bye bye, and take a very good care of your health.